Welcome to Computation Exploration. We are on a journey to experience the beauty of mathematics. As we ponder various mysteries and uncover their underlying patterns, I invite you to join me in that excitement. Many of the topics addressed here have tangible applications to the real world, which makes the process all the more fascinating. Thank you for joining me on this adventure. Let us begin. Welcome to this lesson. Today we'll be discussing division by the number 7. And division by 7. Now you may remember from grade school, there are a couple ways we can represent a number. One is the fractional form, and another is the decimal form. So quick recap, 1 over 2, that is a fraction. As a decimal, we can express that as 0.5, which you can easily verify on a handheld calculator. In similar manner, 1 over 3 is a fraction. The decimal representation is 0.333333. All right, I've used ellipses to indicate that the 3's continue forever. Another notation you might see is 0.3 with a bar above the 3 to indicate that number repeats. Okay, this is the notation I will use for the remainder of the lesson. 1 over 4 is a fraction. The decimal representation is 0.25. 1 over 5 is a fraction. 0.2 is the decimal. 1 over 6 is a fraction, 0.16666. Again, the ellipses indicate that the 6's continue. In bar notation, I will put a bar over just the 6. Okay, 1 and then 6 repeating forever. Okay, so a general rule. Every number that can be represented as a fraction, we call that rational number sometimes, can be expressed in a decimal that either terminates after a finite number of decimal points, as in this case, these 3 cases here, or it repeats in a pattern after a finite number of decimal places, such as these 2 cases. Well, we will soon find that 1 over 7, does not terminate. It is a repeating decimal. So back to elementary school long division. Let's see. I do 1 divided by 7. Well, how many times does 7 go into 1? That's going to be 0. Okay, so that's where I have to start adding zeros here past on the right side of the decimal point. So let's look at this as a 10. 7 goes into 10 once. 1 times 7 is 7. 10 minus 7 is 3. Add a 0, drop it down. 7 goes into 30 4 times. Okay, 4 times 7 is 28. Subtract, that gives me a 2. Bring another 0 down. 7 goes into 20 2 times. Okay, 2 times 7 is 14. 20 minus 14 is 6. Bring down another 0. 7 goes into 60 8 times. 8 times 7 is 56. Subtract 60 minus 56. 4. Bring down a 0. 7 goes into 40. 5 times 7 is 35. Subtract, I get a 5. Bring down a 0. 7 goes into 50 7 times. 7 times 7 is 49. Subtract, I'm left with 1. Bring down the 0. It's 0. 10. I'm back where I started with this 10. So the pattern repeats. That's 1 divided by 7 is 0.142857. Repeating. So I'm going to put a bar over all of these digits. Now notice 1, 2, 3, 4, 5, 6. We have 6 digits past the decimal. The fraction is 1 divided by 7. Okay, 6 is 1 less than 7. That could be important. Anyway, I'm going to write this up here. 142,857. That's 1 over 7. And repeating, 142,857. 142,857. ... Okay, that keeps going on and on forever. Now, this method is all well and good, but I'm going to show you a slightly different approach so that we can observe an interesting pattern. Instead of starting with 10, all right, I'm going to start with 100. Okay, I'm going to go 2 zeros at a time instead of just 1. 7 goes into 100 14 times. 14 times 7 is 98. By subtracting 100 minus 98, that gives me 2. Okay, if I drop down another 2 zeros, 7 goes into 200. How many times? 28. Okay, 28 times 7 is going to be 196. 200 minus 196 is 4. And drop down another 2 zeros. 400. 7 goes into 400 57 times. 57 times 7 is 399. By subtracting, 400 minus 399 is 1. If I drop down the zeros, I get 100, and I'm back where I started with 100. So 0.142857 repeats forever. That's the same result we found the first go around. Okay, so what's going on here? We started off with 100. Okay, now notice 200 is twice 100. And again, 400 is twice 200. So what's going on up top? 14. And we go to 28. 28 is twice 14. Well, then what's twice of 28? That's 56, but because of rounding, it goes up to 57. So a useful trick to remember the pattern is 7 times 2 is 14. 14 times 2 is 28. 28 times 2 is 56. Round up to 57. So instead of remembering a string of 6 digits with no seeming pattern to it, just remember 14, 28, 57 in the way I just told you. So, okay, here's another curious observation. What if we want to do 2 over 7? Well, that's going to be twice 1 over 7. So instead of looking at the whole thing, we can just look at the first number here. What is 14? 14 times 2 is 28. So I'm going to start with the 28. And then notice, again, I go 6 digits before it repeats. So that's going to be 0.285714. Repeating. Okay, you can check me, do a little hand calculation or punch it into your calculator, and you'll find this is what pops up. Same thing with 3 over 7. All right, that's going to be 3 times this. Okay, so instead of doing the whole thing, just look at the first 14 here. 14 times 3 is what? 42. So I'm going to start with the 4. 428571. Again, those 6 digits that repeat. 3 over 7 is 0.428571. Repeating. Okay? Same thing, 4 over 7. That's 4 times that. What's 14 times 4? That's going to be 56. Okay, but rounding, well, we start with the 5, that's 57. Go 6 digits until it repeats again. So that's going to be 0.571428 repeating. Okay, 2 more. 5 over 7. 14 times 5 is 70. So we'll start with the 7. And we'll go for 6 digits. So 5 over 7 is 0.714285. Repeating. And lastly, 6 over 7. Well, 14 times 6 is 84. We start with the 8. And we go for 6 digits. 0.857142. Repeating. All right? So again, instead of memorizing each one of these separately, just remember the pattern. 14, 28, 57. And then it's just a matter of where do I start? Which digit do I start on? And boom, you have your answer. So, let's say somebody gives you a number, 25 divided by 7. Okay, this is a fraction. Let me rewrite that as a mixed fraction. That's going to be 3 and 4/7. Okay, so this is a mixed fraction. To write it as a decimal, that's going to be 3 point. What's 4 over 7? Well, we just found that over here, this guy. So 25 divided by 7 is going to be 3.571428. Repeating. So next time you're given a number divided by 7, before you whip out your calculator, try to employ this trick. And you just might impress someone. Or maybe not. But anyway, thanks for watching, and I'll see you next time. Thank you for your participation in this lesson. I encourage you to keep the conversation open in the comment section below. Your contribution is important to enhancing our understanding of this topic. If you enjoyed this video, please like it and subscribe to get updates on future videos. I will see you next time.